Hello everyone, and welcome to today's discussion over chemical buffer systems that act against changes in hydrogen concentration. We will begin by having a brief overview about what chemical buffer systems are. We will then move on to a more detailed discussion about the numerous types of chemical buffer systems that help maintain homeostasis in our bodies. Finally, we will take a look at what can go wrong if these buffer systems were not in place. Now, if you're ready, let's begin. What is a chemical buffer system? It is a mixture that minimizes changes in the pH of the body by either binding to or generating a hydrogen ion, depending on the addition or removal of an acid or base. They are the first line of defense against change in the concentration of hydrogen in the body fluids and move into action immediately. These systems are composed of a pair of substances that can undergo a reversible reaction. What this means is that when the reaction moves in one direction, one substance can yield a hydrogen ion, and in the other direction, another substance can bind to any free-floating hydrogen ions. We can see this by looking at an important buffer reaction known as the carbonic acid bicarbonate pair. When hydrogen ion concentrations in the body become too low, carbonic acid undergoes a chemical reaction in which it loses or donates one of its hydrogens and transforms into bicarbonate. When the hydrogen concentration becomes too high, bicarbonate is able to bind to the extra hydrogen ions, forming carbonic acid. There are four buffer systems we will discuss a little more in depth. These include the carbonic acid bicarbonate buffer system we have mentioned, the protein buffer system, the hemoglobin buffer system, and the phosphate buffer system. Let's take a closer look at the carbonic acid bicarbonate buffer system. The carbonic acid bicarbonate buffer system is the most important buffer system for non-carbonic acids in the extracellular fluid. This system is readily available for maintaining normal pH values in the body due to an abundance of carbonic acid and bicarbonate. This system is also highly effective because it is highly regulated by the kidneys and the respiratory system. As we can see from the equation, looking at it from left to right, carbon dioxide provided by the respiratory system combined with water to form carbonic acid, which is broken down to form bicarbonate and hydrogen. The reaction occurs in this direction when the plasma hydrogen concentration falls below normal levels. This leads to an increase in hydrogen and pH is restored. Looking at this equation in the reverse order, from right to left, bicarbonate from the kidneys binds with extra hydrogen ions in the plasma yielding carbonic acid. This can be further broken down to create carbon dioxide and water. This chain of events occurs when the concentration of hydrogen in the plasma is too high, and levels need to be lowered to restore a normal pH balance. There is an important equation that is used to express the relationship of this buffering system and the concentration of hydrogen. It is known as the Henderson-Hasselbalch equation. This equation is used to determine the pH level of the plasma. Next, let's move on to the protein buffer system. This system is primarily important in the pH balance of the intracellular fluid. This is due to the massive amount of proteins found in the intracellular fluid. Proteins are considered to be the most plentiful of buffers and are important because they contain both acidic and basic groups. If there is a limitation in the amount of proteins in the plasma for buffering purposes, the carbonic acid bicarbonate system will be reinforced. Another buffer system in the body is conducted by the hemoglobin found in our red blood cells. The hemoglobin molecules buffer hydrogen ions that are produced as a result of our metabolic pathways in conjunction with carbon dioxide. When carbon dioxide diffuses into the bloodstream from our muscles and organ systems, it combines with water to form bicarbonate and hydrogen when influenced by an enzyme called carbonic anhydrase. These now free-floating hydrogen ions bind to hemoglobin, thus reducing their acidic contribution. If the hemoglobin did not clean up this excess hydrogen, the blood would become acidic. But, since it performs this action, the blood of the venous system is only slightly more acidic than the blood found in the arterial system. This is primarily due to the higher abundance of carbon dioxide. This buffering system is heavily reliant on both the circulatory and respiratory systems, as well as the abundance of hemoglobin. The last buffering system we will talk about today is the phosphate buffer system. This system consists of both an acidic phosphate salt and a basic phosphate salt. The acidic salt is able to donate one of its hydrogen ions when the concentration of hydrogen in the plasma begins to fall. The basic phosphate salt accepts any excess hydrogen when concentrations are too high. These substances are not as readily available as carbonic acid and bicarbonate in the extracellular fluid, so therefore it does not do an efficient job of buffering. This buffering system is more utilized within the cells in the intracellular fluid, where these salts are more abundant. It is especially beneficial as a buffer system in the urinary system. Our daily diets typically consist of more phosphate than our bodies are able to reabsorb. However, this extra phosphate is not wasted. Although it is still excreted by the body, while it is in the tubules, it binds to excess hydrogen ions, thus buffering the urine that is produced. This is the only means of buffering at this point of the urinary system, since most of the carbonic acid and bicarbonate in the plasma fluid has been reabsorbed by the kidneys, and other buffering systems do not reach this point of the urinary cycle due to lack of filtration. When the buffering systems of the body do not work as they should, there are a few possibilities that can occur. The first that we will mention is a condition known as metabolic acidosis. It is a condition characterized as the increase of hydrogen ion concentration in the plasma that leads to an acid-base imbalance and a decrease in the concentration of bicarbonate. It is a serious condition that oftentimes signifies an underlying condition. There are several events that can lead to this increase of acidity, which include a decreased ability of the body to excrete acid, an increase in the production of acid, ingestion of acidic substances, and losses in bicarbonate in the renal or gastrointestinal systems. Another condition that can occur is metabolic alkalosis, which is the increase in plasma pH above the normal range. This typically results in an increase in the bicarbonate concentration and a decrease in hydrogen. This condition can result from gastrointestinal or renal losses of hydrogen, an intracellular shift of hydrogen, or the retention or addition of bicarbonate in the plasma. It can lead to conditions such as arrhythmias, confusion, decreased cerebral blood flow, decreased myocardial contractility, and increased neuromuscular excitability. And this concludes our discussion over chemical buffer systems. In order for our bodies to function properly and efficiently, it is vital that pH levels are kept within a normal range, and these systems work hard to do just that. I hope that you found this video informative and supplemental to your studies. As always, I wish you good luck in the rest of your studies and have a wonderful day.